Alright, let us try to revise the past paper 2016 paper 2. And to get started, we've got 20 marks for section A, and that is multiple choice. Alright, so we're answering the questions. Let's get on with question number 1. The diagram below shows the changes of state. We have liquid to gas, then solid, solid, liquid, gas. Okay, which of the following sets of changes are exothermic and endothermic? Okay, which ones are exothermic and endothermic? So we'll look at this and we can clearly just check out. Before we answer this, we need to know what is an exothermic reaction and what is an endothermic reaction. So an exothermic reaction is a reaction that produces heat, and then endothermic reaction is a reaction that needs heat or takes in heat for it to happen. So let's see which one is exothermic and endothermic. So A says 1, 2, and 3. So 1 is from solid to liquid. So the best case scenario we can imagine is water changing to ice, then water vapor. That would be the best case scenario or best example we can refer to. So imagine a solid ice here changing into liquid. What do you need? You need to apply heat, and it's going to absorb heat for it to change to liquid. So 1 definitely is endothermic and not exothermic. So A does not qualify because it has got 1, which is from solid to liquid. We know that it's melting, and melting takes in heat. It doesn't release heat to the surrounding or the environment. So wherever there's 1, it is not correct. 1 as exothermic is not correct. So A is wrong, as well as B, as well as D. So which leaves us with C as our best option. So C is the best answer that we have. So when you're answering multiple choice questions, the best way to do it is to use elimination method. You eliminate those which are definitely wrong, and then you leave yourself few options at the end of it all, and that will make it easier for you to choose the correct answer. Question 2. I'm running through this rather pretty quickly so that we can rest with time. Which of the following apparatus can be used for separating immiscible liquids? Now, what are immiscible liquids? So we have this, and we have that. So what are immiscible liquids? These are liquids which you cannot mix, okay, and they cannot be mixed. They cannot. So here you can see we have some beaker with the separating funnel, and then this should be we have a crucible, and this instrument here. Then D. So which is best? Which instrument can be used to separate immiscible liquids? The best one would be B. That definitely is a separating funnel. So separating funnel is the one that you use, because you have one settling there and another one probably settling there, and you can use that to separate immiscible liquids. So 2B. What is the volume of the question 3? What is the volume of the liquid in the measuring cylinder? What is the volume of the liquid in the measuring cylinder? Well, we have to know where do you measure from. So we start from here going upwards. That is 20, somewhere close to 29. So we have 1, 2, 3, 4. How many do we have in between 30 and 40 here? You can see how many we have. How many divisions do we have? We have 1, 2, 3, for 5 divisions, so each division is a 2. Okay, so from 20, this we see that we are exactly on the last division, so this should be 28. That should be D as our answer. So D should be our answer here. Then we come to 4. And by the way, you can pause the video before you watch the answer as we're doing it together, so that you find your own answers before we do things together. The elements X and Y have the following nuclides: 28, X 14, and then 16, Y 8. What is the correct chemical formula for the compound formed when element X reacts with element Y? So we need to look at the electronic configuration for each one. For X, the electronic configuration will be it has got 14 electrons. So we'll have 2 in the first shell, 8 second one, and then we'll have 4 the last one. For Y, we're going to have 2 in the first shell and 6 in the last shell. So okay, so what we're going to have here is we need to share these are like non-metals. These are non-metals, so they are going to share electrons for them to form a bond. So you have X and Y, and now you need two of the Y's they'll share 2 electrons from here. That means 2 of 6, and another 2 from another one of Y, and you have we have in the final shell we have 2 of Y, so it will be X 2 X Y 2. That will be the chemical formula, which is A. So they're going to share electrons from the 2 of these. We share electrons to this. 5. All the isotopes of an element contain a different number of electrons. Okay, so with isotopes, know that these are elements with the same number of protons. So we have got the same number of protons, but different neutrons, different number of neutrons. Okay, so all the isotopes of an element contain different number of electrons, not really different number of protons. No, the same number of protons, the same number of protons, but different neutrons. So C is the correct one. Given that the relative formula mass of a compound is N2X203, that's not how you read it. Given that the compound is sodium, okay, that we don't know how to read X there, so is 158. That is the relative formula mass of a compound. What is element X? So really, what is the relative formula mass? What is the relative formula mass? So the relative formula mass is the total relative atomic mass of all ions in a formula. So if you have an ionic compound, so all the relative atomic mass of the ions in the formula, the relative atomic mass of all atoms in the ionic compound is what we call the relative formula mass. So the relative atomic mass of all atoms in the ionic compound is what we call the relative atomic mass. So from here we need to find the relative atomic mass of each atom. Sodium atom, you look at the periodic table, then check out what is the relative atomic mass. You multiply that by 2 plus X times 2 16 for oxygen, then we do that, then we equate it to 158, and then okay, so let us jump to the periodic table. So let's check the periodic table for sodium. So we need to find first what is the relative atomic mass for sodium, and we come here, look where sodium, that's our periodic table. Checking where sodium is, it's exactly here. So for sodium we have the number there on top is the relative atomic mass. So the atomic masses of the relative atomic masses are already stated on the periodic table, which are these numbers on top. You are seeing hydrogen 1, helium 4, lithium 7, beryllium 9, sodium is 23. Okay, so we come back and then we know that for sodium the relative atomic mass is 23, and then we have 2 of those, so it should be times 2, that is here. And then for X, which of course we don't know, we'll just say it is X times 2, which is X2. And then we have oxygen, and then we got the periodic table, should be 16, oxygen here 16, and then we say 16 here. How many do we have? We have 3 of them, so times 3. So we say this is 23 times 2, 16 times 3, plus, then we add everything, plus 2x, and then we say they should give us 158, because that's the relative formula mass of this ionic compound. So at this point I'll allow you to get your calculator, and then you know 23 times 2 give you 46, then you say 46, so that is 46, not 14, should be 46, 46 times, that is 46, plus 16 by 3, that should give us 48. So we have 48 plus 48 plus 2x, 2 times x. Okay, it's not a small x, capital X. So it's 2x. So this will give us 46 plus 48, and then we get 94. So this should be 94 plus 2x should give us 158. Then we know this would be 2x is equal to 158 minus 94, 158. Because that, so why are we doing this? Because we know they told us that the total formula mass is 158. Well, the formula mass is 158, the relative formula mass, and then we know the atomic masses for these 2, oxygen and sodium. So we just have to make an equation equating this, and then we find what x is. So here, if 158 minus 94, so 158 minus 94, what do we get? We get 64. So this should be equal to 64. So 2x is equal to 64, so we divide. I'm going to bring it here, everything by 2, there by 2, it will cancel there, 2 into 64, so x is equal to 32. So now this is the relative atomic mass of X. Now what element has got a relative atomic mass of 32? So we go to a periodic table, we check which one has got 32, and we'll come here, sulfur, here it is. Okay, so we know that sulfur has got here relative atomic mass of 32. So we come here, we check where sulfur is, D is where sulfur. So D is the correct answer. Okay, so that's what we have here. So just to recap again, so relative formula mass of a compound is 158, meaning you have to find each relative atomic mass by using the periodic table, and then make X, solve the equation for X, equate everything to 158, and then solve for X. Then X give you the relative atomic mass for the compound, for the element you're looking for. Check on the periodic table, sulfur. What is the mass of 0.2 moles of chlorine molecules? So we've got 0.2 moles of chlorine molecules. What is the mass? Okay, so we know that number of moles should be equals to mass divided by what? Molar mass. Mass divided by molar mass. So we know the number of moles. They've told us we have 0.2, and then we want to find what is the mass. So what is the molar mass of chlorine? So when we talk about molar mass, we are talking about the for substances made of atoms, it's just the same relative atomic mass we are talking about. Okay, so you just check on the periodic table. What's the molar mass? You just go ahead and check on the periodic table, and for chlorine, you've got this. It's a molecule, and the molar mass is the mass of 1 mole of substance, or 1 mole of atoms. What is the mass of that? So for chlorine, when we go on the periodic table, we check, we find it is 35.5, and now is di, so it's 35.5, but in this case it is diatomic. There are 2, so we multiply that by 2, and then so we say the mass will be 35.5 times 2. What do we get? We get 71. So it's 71 multiplied by 0.2. What do we get as the mass? So times 0.2, we get 14.2 grams. So our answer here is C. So let me just mention, I would recommend that for chemistry, if you want the best book, which I would recommend for chemistry, it's very good, it's amazing chemistry book. This is a very good book, and it's very simplified, so to say, but it has got relevant information that you need, details, so that you can be able to get the concepts easily. So what I'm talking about, you can just a sneak peek from the book. You can see everything we've been talking about, the molar mass. This talks about the particles, the mole, the relative formula mass. It's a very good book. I recommend that you get this book. It's coordinated by written by Evans Mumba, which is myself. So it's a good book. I recommend that you get this book on the market. I think you can find it. You can find it at City Market. We're one of our stores there, or you can call the number and we'll deliver it to you, which is at the end of this video. You'll have it delivered to you. All right, so that is it. And for more of these questions, and to be able to register for tuitions also, I must mention, you can call the number, we'll get you registered. You need to register for full classes. Trust me, I cannot emphasize or stress enough how important these online tuitions are and how much they'll help you. Please do that. Okay, so question 8, 2 grams of ammonium chloride is dissolved in 20 centimeters of tap water.